Alright, I'm back. This is the first time I've done this in a very long time, so we're gonna do a quick audio test just to verify that I am doing what I'm supposed to be doing. Alright, it seems like everything is working the way it's supposed to, so let's go ahead and jump right in. A couple of months ago, somebody on my Twitter feed uh, said something about a .NET deck implementation, and I thought that was kind of interesting. My wife plays a lot of card games, and I figured why not? It'd be something fun to do. I've also been playing around a lot with dynamic data recently, and dynamic data has a sort function which will sort, and it also has an update function that will I'm sorry, an index concept that it will index what's in your list and project the index changes, and you can update the indexes when things get sorted or moved around or removed from the list. So I figured um, I was working on something else for myself, and I needed a randomized method. So I I created a random method for dynamic data, and I kind of just wanted to use it in this deck implementation just as a way to see if I could use it for like the shuffling. So I'm gonna jump right in and give it a go. As you can see here in front of us, there's this is the README for the for the Git repository, and it's basically just giving us a simple deck data structure. We're not gonna try and break the bank on this one and create the next you know you know auto shuffler 3000. We're just trying to create something simple that we can play with and use and see some interesting patterns along the way. Uh, so I'm gonna jump right in. I've got some. I've actually got some of this code already written, if not all of it. So we're gonna try to short circuit some of it and keep everything going. I am gonna point out that. There we go. Clicking buttons. I am gonna point out that the only things that I have in here right now are this dynamic data and system.reactive. That's all I'm going to need in order to be able to build this. Again, there should be no secret at this point. I like RX, so I like to do RX based solutions. So let's kind of go back here and define what the deck needs to do, and then we'll kind of take a test driven approach to making this happen, right? So we'll go ahead and we'll start with failing tests and go through that whole process. So let me go ahead and get a timer started here so that we're not rambling on for hours upon hours upon hours. Oh, clicking buttons. People close to me will tell you that I am the best person for clicking buttons. If you need buttons clicked, call me because I will not click them. Uh, Let me find the right button. What does this button do? Okay, well we'll do it this way. We've got a timer on our desk, and we'll go ahead and get it going. So the the first thing that we're gonna talk about is like that a deck is gonna be immutable. Once the deck is built, you can't add cards to it. I don't want a mutable data structure. I want an immutable data structure. Um, Shuffle, there's going to be a concept of like maybe in a like let's consider a blackjack game where you only use 4 or 5 cards, then you would have to reshuffle the entire deck back in, right? So we've got a concept of shuffling the deck, but we want to make sure that we can shuffle the remaining cards, right, or shuffle everything back in. And then a simple cut and draw, right? Because when you're playing a card game, what do? You shuffle the deck, you pass it to the person to your right to cut, and then you either deal or draw. We're gonna use draw instead of deal because I don't want like I don't know what the right no like naming is for it, but dealing it kind of implies handing out cards to other individuals, and we don't really know whether or not that's going to happen. But we are going to take cards off the top of the deck, which would be drawing off the top of the deck. So off we go on another adventure. So to get this started, what I'm going to go ahead and do is I'm going to create this wonderful little interface. I'm going to go to class interface iCard. So the one thing that I didn't know whether or not I could get around and actually didn't want to get around, don't ask again, cancel. Um, what I didn't want to really get around was having some interface that you have to conform to in order for this to work. Um, there's a couple of reasons in Dex Aware. There's a couple of reasons. The primary reason that I'm going for is That's weird. The whoop, clicking buttons. See, there I go, clicking buttons. The primary reason that I'm going for, oh, it's a class. That's why it didn't pick up. I didn't pick it up as an interface. Um, the primary reason that I'm doing the card interface is so that I can get access to this index and get access to the randomization. So like, let's consider that you have a 54 card deck. You would have a deuce of diamonds and a deuce of spades, for example, right? For those of you that play spades, you probably, joker, joker, deuce, deuce, right? So imagine you have the deuce of spades and the deuce of diamonds. Well, those would be explicit for the two of a given suit, and I didn't want to go down the road of imposing a actual deck of like playing cards, because I know there's other type of card deck type stuff that you can do in games, like you could have an Uno deck, and Uno doesn't really follow the same rules, right? So really what I want is each card to have a unique index. So I'm using this iIndex aware from dynamic data, and I think this allows me to update the index, but this doesn't actually explicitly have anything to do with sorting. Um, so I'm using the concept of the deuce of spades would be, card number 16, and the deuce of diamonds would be card number 17, as opposed to getting into the explicit having a card, having a suit, having a color, having whatever. I don't want to segregate it based on that. I want to keep it as generic as possible, and I'll tell you why. I had to write a tic-tac-toe program back in college, and I was hell-bent on using a two-dimensional array, and come to find out that my professor told me that you would have had an easier time implementing it if you just use a single dimensional array. My brain didn't even think about that, because I'm thinking, you have a 9 by 9 grid, right? That's how it works. Well, so I'm trying to keep everything as linear as possible, and not get into any type of linear algebra, as it were. So I'm going to create this card interface. So basically anything that extends from this card should be viable in our deck. And I want to give it an explicit identifier, right? So you can name it whatever you want, don't care. I'm going to make it a string specifically to make it easier for everybody to go along with. So that gets us the card interface that we want to start with. I think where we'll go next is we'll kind of get into the meat and potatoes of a actual deck implementation. Let me see if I can find my Solution Explorer. I probably shouldn't get rid of that. That way I don't have to. Ooh, Key Promoter is telling me that I am bad at clicking the buttons. There we go. And we're going to bring the test window back up, because I think we're going to jump right into writing tests. So over here we've got some tests. So what I think I'm going to start with is bringing up the reality that I want to have a card deck. And this is going to be a composition relationship. The reason why I'm making the thing that you're going to extend from your individual object as iCard is because I'm going to give you a generic wrapper around anything that implements that iCard. So we'll go ahead and see what that looks like. So we're going to create a card deck, and we're going to give it a generic type, and we're going to make this extend read-only collection because we want to do some magical stuff here. We want the card deck itself to be a list of cards. So we will implement the missing feature. That means it's going to have a get enumerator, T, and a count. Cool. So we implement that. All right. So that gives us the skeleton of this. And I think before we go any further, we're going to go back to our requirements and see if it's time for us to start writing tests. So once the deck is built, you cannot add cards to it, right? So can we test that? I don't know that we can actually test mutability, but we can test that once the deck is constructed, or better yet, we can explicitly have it so that there is no add method. So I don't think we can actually write a test for that, or we want to write a test for that, because I feel like it'd be brittle. But we're going to just continue down the pathway. So I think we'll get directly into just the creation of the object, and then probably get into how we're going to do this shuffling, because then we'll get into some of the randomization stuff, and we'll have some fun there. So at this point, I don't think it I even have tests? Okay. Yeah, so I don't think I even need tests yet, but we'll go ahead and create this, change this to card. Whoop, F12. There we go. Card, or F2, deck. Anyone who's watching and knows the rider key binding is like, what do you mean F12, Rodney? Yeah, I know. So we've got our class for card deck test. We'll make sure that the rename the file to match the type so everyone's happy. At least I'll be happy. Maybe everybody doesn't care. But at this point, I think I've got enough to start building out what I want. So let's go ahead and look at, I'm just going to look at the code that I've already got written over here on this other screen. I don't think there's anything. So we'll start by testing the count property. I think that's where we're going to start. I'm going to use a pattern that I don't know if I still like, but I used it a while ago and I'm trying to find a better one. So if you see this and you have a better way to do it, feel free to leave a comment somewhere. The reality of it is that I've also been playing with the concept of partial classes to group tests together, but to allow them to expand separately. But today I'm just going to use the technique that I'm used to using. So the public class count property. Yeah, there we go. All right, so I've got this count property that I want to test, which is going to be the count property on the card deck, right? And what are we going to want to do? Ooh, oh, yeah, there we go. I've got rider niceties. I've got live templates to generate my unit tests for me because I'm a nerd. So given that we have cards, when the deck is constructed, then it has a count, right? And I think what we want to do, and I'm gonna start pulling code over from where I have it because I don't like to test stuff like this with just one input because sometimes that one input can be brittle. But type of, come on, you can do it. So instead, what I like to do is I like to give theories here and provide a set of test data, just so that I can randomize it a little bit and give myself a little bit of wiggle room when it comes to some of this stuff. All right, so I'm gonna grab my full deck test. I'm just gonna dump this out here. IEnumerable. Let's go ahead and yeah, you should be able to. No. Wait, I just okay, I have to be able to do both. And I guess I need to actually create a type for this now, don't I? So this is where like the whole test-driven development, only write the amount of code that you need in order to pass the test, kind of falls down for me because as you see, I'm writing a whole bunch of ancillary stuff just to be able to get to the point where I'm writing a test. In the long run, it'll be worth it, I think, but for the moment, it's kind of awkward. So let's go ahead and implement the missing members. So we want to have an index. We have a get set on our index. We have a get only on our identifier. We want the identifier to be above the index only because we really like alphabetized things and stuff. We'll do a pub. Yeah, someone's gonna yell, Rodney, you don't use the. Yep, there we go. But we don't need the index, so we'll get rid of the index. And because it's a playing card, and because we just said earlier that we can do anything we want, we'll do this, and then we'll explicitly do a .to string, right? There we go. So that gets us kind of where we want. But I think we, you know what? We might do this on the interface at some point. But I also want this to be. Nope. There we go. Comparable to an iCard, and there's a reason for that. When we get into so. The reason for that is Dynamic Data has some really awesome stuff around sorting for us that we're going to take advantage of, and we're going to use the sorting engine that Roland built. We're going to use it to implement this randomization. So we're going to kind of cheat and use that iComparable too, so that way we don't have to do anything too extra. Do we just have iComparable iCard? I think we're going to just grab all this right here. Yep, there we go. And then we're going to say that the compare to of the iCard is going to be string dot compare the identifier and other dot identifier. Now, when you implement this, you can implement this however you so choose, right? But I'm just doing this now for the posterity of it all. And then we'll do string comparison dot ordinal ignore case. Sure, let's do that. Just because we want to make sure that we're ignoring case sensitivity because it could be a thing. And then, oh, we're not having to implement the iComparable though. So, that seems weird, but we'll come back to that. If we need to implement it, we'll implement it. So now we have a playing card, right? So this is going to be like a regular spades or bid whist, gin rummy, what other card games you can think of. There's so many of them. Like I've been introduced to so many over the past several years. Being at home, having nothing better to do. Oh, this needs to be card deck. How is that even possible? Where? Card deck. Oh, yeah, there we go. I need to create this class if I have it. Oh, ha. I need to change this to test card deck. This is then going to implement internal class test. Just paste it off our clipboard, right? Which is going to be enumerable of playing card. All right, so now we've got this is just all test fixture set up at this point. So I apologize. This is the boring stuff. Let me tell it. I wonder if, nope, still doesn't do all of them. Yield break, but we want to create a concept of a full deck. So we want to create a full 52 card deck. So we do a private read only enumerable of playing card, and we'll call this underscore full deck equals enumerable. Let's actually hit a carriage return so we can enumerable. I think I actually want range. Yeah, I think I want range. Let's go do this. I want range 0 to 54. Then I want to do a dot select. Let's call this the index. Oh, I think that's actually technically going to be the identifier, isn't it? Yeah, let's change that to the identifier. Right, yeah, and then we'll do new playing card, and we'll pass in the identifier. Boom. So now we have a full deck, and when we spit this thing out, instead of doing that, we will just return the underscore full deck dot get enumerator. Right, okay, so now we have a construct for our test output. We've got a test, we've got a full deck. That full deck gets a test deck. It will return a full deck. Now that means that this test has to change. Come on, you can do it. It will have to take in an enumerable of playing card. Give that a cards. We're actually going to close this down for the moment. We'll close that down so we can get some more real estate. Yeah, accessibility is less accessible than the... Oh, womp womp. Okay, fine. It can be public for all I care. I just, Or wait, does that need to be public? Let's go look. Yeah, let's just go ahead and make it public. For whatever reason, it's been defaulting to internal recently, which I don't mind, actually, because I'm starting to use that keyword more and more. Where's the error? The actual. Oh, it's down here. Semicolon. Wah, 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 wah. All right, so now we've got this set of cards. What we're gonna do? Oh, I think we need to make a fixture too. Ugh. Fixture. I need a card deck fixture, and that fixture needs to be of, I believe, type T. I don't think we have system reactive testing in here, do we? Let me see. Oh, let's see. I think I have rocket surgeons in here. I test fixture builder. Yeah, there we go. That means this is going to become, come on. This is going to have to take a generic type. This is going to have a generic type. This is then going to have to be a type T. You can tell I do this so often, right? You're going to need a full deck. Numeral of T. Full deck. Empty of T. Alright, so that has something, and then we give it underscore full deck, and then we'll go Oh, this can't be T. It has to build a card deck of type T. Now the build method resolves. You are still complaining because card deck T. Oh, yeah. Okay, so here we are. Finally at the beginning of all the fun. We now need to create a constructor that takes in an IEnumerable of T, and we'll call that, instead of calling full deck, we'll call that cards. And I think we actually want to make that change back there too. Alright, so now we've got cards. So this covers the concern of once the deck is built, you can't add cards to it, right? So that means that now when you provided an IEnumerable of your cards, you can't add any new objects to that structure, which is fine for us because that's the way we want things to work anyway. Let's go back to our tests. So I think we're at a point where we can actually start writing our test for the count, and we can say with card fixture with cards. Yeah, I think we're gonna do this as an IEnumerable of T. Input is going to be cards. Normally I would do like parameter arrays, but because I know I'm taking in an IEnumerable, it just doesn't make any sense because I have to explicitly do a .toArray underscore full deck, which we're going to rename to underscore cards. There we go. All right, so we've got that. That needs a T. All right, so what we can do now is we can actually start our test. So we can say, given we have a card deck of T, given we have a card deck of oh, sorry, we can't do just T. We have to give T an actual thing here, playing card. So when we have a card deck of playing card, SysMotor test is going to equal new card deck fixture of playing card. So this is the composition bit. We're going to give it cards of cards, right? We are composing a thing around playing cards that does some stuff, right? So this is where I usually break down and talk about composition and inheritance. Like there's a concept of composition versus inheritance. There's also the concept of competition with inheritance or composition with inheritance. What I'm doing is I'm using a composite class to write something around some stateful thing. I'm starting to like this approach more and more. It's something that I noticed the state objects do in a framework called Flutter. Uh, but overall, from a reactive perspective, from a state design pattern perspective, I'm really enjoying the concept of I have a thing that gives me information. I can write a wrapper around it to give me a consistent understanding of how to interact with the bells and whistles of my object. So the more I play with this, the more I start to like it. Pardon me. All right. So what we want to do is, I guess we can shorten the win then. So when it's constructed, because as soon as the system under test is constructed, we know this thing should have count of 54. All right, so let's go. Oh, you know what? Let's start with 0, just because we want to prove that the test fails first. We want to try and stay true to our test-driven ideals. Oh no. Let's try the terminal then. Let's do list. Let's do .NET restore current working directory. cd src list. Where, pray tell, then, is my solution file? Don't tell me I don't have a solution file. I have to have a solution file. Otherwise, load failed, not built. I call shenanigans. Let's go to the videotape. All right, yep. Yep. How about them apples? So we don't have. All right, we can fix this. We can fix it. Edit. Let's create. Let's do this. Let's do a new file. Deck dot. Pay no attention to the man behind the curtain. Yeah, that should do. I may need to no. Haha. Rider is awesome. It immediately figured itself out. That is phenomenal. Let's just go back and do, let's actually cd go back. And then let's do our .NET restore. And now we know that the .NET restore should work. Yep, okay. All projects up to date. All right, so .NET build, just for our own sanity at this point. It's taking its sweet time, isn't it? All right, no errors. So let's go ahead and run our unit test, watch it fail, and then we'll go ahead and get it passing. And then we're going to kind of jump into the meat and potatoes of how all of this is going to work. Oh, look at that. Our test passed. Why did our test pass? See, that's exactly why you got to do stuff like this, just to be sure. 0 to 54. Test deck card, yield return, object full deck. This with cards. Okay, so all that should work. Let's see what this. Let's debug it then. Gotta love it when the simple stuff breaks right early and like right out the gate. It's phenomenal. Let's see how this goes. All right, so it definitely has values. Oh, enumeration yielded no results. Okay, so it is giving us a problem. What could that problem be? So we're converting it to the playing. Let's go to the card deck. Let's check it out. Ah, do you see the problem? I see the problem. See, we didn't implement anything. That's great. So now in here, what I think we're gonna need to do is let's call this. Let's introduce a read-only field called cards. Let's explicitly .toList .as read-only. Just because, let's change this from an I enumerable to an I read-only list. Oh, we're using collections. Let's use collection. Oof. Oof. I read-only collection of cards. All right. So now we have cards. So what we'll do here is we will return cards dot get enumerator, and this will return underscore, for the moment we'll return underscore cards dot kill, right? I think that's sufficient for the moment. All right, so now we're saying that, let me move this to the bottom. Mode file, all the way to the bottom, private's at the bottom. It's my new jam, just don't tell anybody. Okay, so now what I'm saying is that when the cards come in, the enumerator will return the cards and the count will return. So now when we run this, so brilliant. I could have just started with the 54 for the count and been done with it, but no, I had to prove that the test has to fail first. Yay, now it's red. Thank you, Ryder. Ryder's awesome. Alright. So now I can put my 54 count in here and run this unit test again, watch it pass, and be happy with myself. Alright. Alright, so now I got a green light, so I should be happy. So let's go back to our deck and let's start talking about what this thing is supposed to look like. Alright, so we've established the cards, we've got the count. So what's the next thing? Let's go back to our README and see what our requirements are. Okay, so we've satisfied that this is built once and that it's enumerable. So let's go ahead and check that box. So let's start talking about shuffling, I guess is probably the next place to go. So this is where we're going to get into like the fun of things. And I'm not going to write this code live, so I apologize if you thought I was going to sit here and write this live, but I will talk about what it does, because if I write it, it's just going to take too long, but if I bring it in and talk about it, it'll be a lot easier. So I'm just going to paste all this code over here, and we're going to kind of go through and see what it does. Okay, maybe paste doesn't work. Maybe copy doesn't work. Let's copy and let's paste. Oh, this may actually force me to do everything manually. Let's see how this goes. Copy. We're gonna try this one last time. Okay, so we're gonna have to do it the old-fashioned way, huh? So much fun. All right, let's do it then. So there's a couple of things that we have to bring in just to get dynamic data under control. So there's a couple of things that are internal to dynamic data that we don't have access, that we have to copy outside of dynamic data in order to be able to do. What are those things? We are going to have a class called a key value collection. That's just going to provide us the ability to have a actual key value collection. Yep, everybody's gonna be upset here shortly. Okay, so yeah, okay, yep, and then I need to bring in my randomization compare. So this is where things start to get fun, right? So let's actually do this from the beginning, from the top, right? What I want to be able to do, and I know I'm deviating from my test-driven approach. What I want to be able to do is randomize the items in a dynamic data cache when somebody calls the shuffle method. So extensions. And in order to do that, I'm tying into dynamic data's ability to properly sort. Target. This. Oh, yeah, this may not have worked when. Oh, this may only work if so I do have to bring in reactive UI for now because I do need access to when any value. Include reactive UI version 17.5. I think we're further up than that, but I think I'm just going to go with that for now just because it's the first one that popped up. Okay, so let's go back in here. Alright, and that's random, so we need to create that class in a minute. We'll do that. Oh wait, yeah, we need to create that class in a minute, so let's go ahead and do that. And then let's go back to the deck and let's add our dynamic data cache. So if I am looking at the card deck, I want to have down here my private read-only bits, my source cache. I want to have a source cache of t comma string. I think that's what the thing is going to be. And then we're going to have a deck cache, new source cache, x dot identify. Did we not give this generic type constraint? Oh, we are brilliant. Okay, so let's do this. Where t I card, right? So now we can go back over here and explicitly call our identifier, right? There we go. So deck cache now needs to be loaded, so we'll go ahead and just say deck cache dot edit updater dot load. I think we want to load the underscore cards. I think we actually want to rename this to full deck because we may need that later in order to implement some of the stuff we want. Okay, so we're going to load the full deck, and then after we load the full deck, we're also going to say deck cache dot connect dot randomize random. Yep, because we have our extension method. So we're going to provide it this, and we're going to say it's going to be a deck, and the deck dot shuffler, and then we're going to say false. So we're going to talk about this in a second. I'm going to finish writing it out. Update index. We're going to bind this out. We're going to bind that out to the remaining cards, and then we're going to subscribe to this. Cool. All right, so let's go ahead and implement some things. This is going to be an, right now, I think we're going to use a read-only observable collection. I don't think I care at the moment. Didn't spell that right. Thank you, Ryder, for telling me that I'm a horrible speller. Remain. Remaining cards. Remaining. Oh, gosh. Still can't spell. Third time's a charm. All right, cool. So remaining collection, and then we're gonna have to have this shuffler business. So this is actually going to be, we're gonna create this as an I subject. Actually, I don't think I necessarily need an I subject. I should use subject of unit. All right. Let's do that just for reasons unbeknownst to us. Make it read-only. This thing can go to the top. It's the only non-read-only one. All right, so what are we doing here? So, okay, so what we're saying, what I want to be able to do is load a dynamic data cache with the cards, right, that I'm getting in from the constructor. And then I want my dynamic data, my deck cache to connect, randomize, update the index, and then bind out. So something that I wrote in this random function is whether or not to randomize immediately. I can have this thing tick a value immediately, but I don't have it doing that. Hold on one second. Apologies, I had to blow my nose. I feel like it's rude for me to blow my nose in front of folks. Just relax, pup. All right, so now that all of this compiles, we'll kind of bring in the rest of the bits and we'll start talking about what they do. So this is my random extension, and again, I'm even using the sort, full on using the sort pieces out of dynamic data. I'm just extending dynamic data to bend to my will. I'm creating a new random bit, so let's pull in the random. Do the random. We're gonna pull in this whole thing. Yep, and we're gonna cheat and put everything in one class because we easily can now. Paste that in. We're gonna grab all of. Yep. You can do it. You can do it, computer. So I did an Apple update about a week or two ago, and I feel like Apple is forcing me to get a new computer because all the things that I used to be able to do without my computer dying, I no longer seem to be capable of doing them, which is great, right? Like the same workload that it's been using for years, it now no longer seems to be able to handle it. And the only thing that changed is I got a YubiKey and I updated Mac OS. So one of those two things is causing the problem. And if it's the YubiKey, I don't really lose a bet, but someone's gonna point and laugh at me, like Nelson from The Simpsons. Come on, you don't understand unit. And I recently had a conversation about this unit bit, right, where I'm trying to get the .NET team to create a unit that we can use as a placeholder for a return type, very similar to how task is just a return type. I won't go as far as saying that we shouldn't use void anymore, but using void can cause problems at times, whereas you having to return a notification of completion is, in my opinion, preferable. Okay, how about this? We will grab, I think we have the comparer. I think we have the comparer, and I think all we need left is the calculator. So let me grab the calculator, and we'll go through some of this code, maybe not all of it. Oh, that's your problem, Rodney. You're brilliant. No, that's internal sealed class. Oh, okay. This needs to come out. This needs to come out. These are not private. Oh wait, no, the randomizer is a private class, but this needs to be an actual internal class to the entire of the application. And then we need a random comparer, which I think is what we should have just gotten. But if not, what we'll do is we'll grab everything and then we'll expand it out into its nice, pretty place. Come on. Come on. Alright. So we've got 15 errors. I'm going to click some buttons and do some things and clean some stuff up. That's actually named key value collection, so we want to grab another class. Unit still won't resolve, which is entertaining. Oh, now unit resolves. Wah, 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 wah. I'm so good at this. So good at this. Move everything in the file to its own file. And then we'll talk about the way dynamic data is set up. So, okay, so this extension method is an extension on top of an iObservable of iChange set of object and key, which comes from a source cache. Simple enough. Then in my extension method, the way Roland has things set up, he creates these new observable bits and he calls the run method on the object to allow it to project the observable changes that we want. So I created this random object. This random object takes in a set of changes. It takes in a sort optimization. It takes in a randomizer, which is important. It takes in a bit to tell you whether or not you should randomize immediately. I'm thinking I should default that to false, but maybe the default behavior people would want is to automatically randomize on the first go round. I didn't elect for that, but I added that in here as a bit. And then the reset threshold. So I'm taking a lot of this directly from the sorting concept and the way that commands are indicated in reactive UI. So I've got my randomizer, which is another class that I create that just does the randomization. Like it's really small, lightweight. It just do the random, right? And again, this is all based on how Roland has everything set up in dynamic data. So I'm not really deviating from any patterns. I'm really just kind of following the pattern. So if you ever want to look at the pattern, I would recommend going to Reactive Marbles /dynamic data on GitHub and checking out these internals. But long and short, what it's going to do is it's going to do some randomization for us, right? So I guess we could technically test it, but I don't think we're going to test the randomization as much. Alright, so that's and then we have an explicit random change set, which is an implementation of an iSorted change set. Now I probably should have an iRandom change set that inherits from iSorted change set. I'm not going to worry about it. The reality of it is it's still a sorted change set, so it still follows what it is to be sorted. It's just sorted by a random comparison method. Okay, so that's all just comparison logic, and stuff. So there's a random comparer, right? So this is where that iComparer and iComparable come into play. I'm going to be looking, I've got an iComparer, and this is why we had to have that iComparable earlier, so that we can look at a given bit think we're using the actual random. Yeah, that's the actual .NET Random class. Perfect. So we're using the random to randomize whether or not a given value uh, is comparable to another value in our system. Let me clean some of these things up because I like the expression bodies. And then this is the actual calculator that actually calculates the randomization for the list. It's the one that's actually projecting the change sets and doing the key value pairings and all that fun stuff. There's an actual calculate method here, which, oh no, it's telling me it exceeds cognitive complexity by way too much. That's probably because there's a bunch of for each. Yeah, it's got for eaches and case statements in here. So yeah, and then more for eaches and more stuff. So this is a pretty complex method. So I get why it's telling me that, and that's fine. But going back to our card deck, what that tells us, or what that gives us, is the ability to randomize the. Oh, I don't need to ref count it because that's the only usage of it. Okay, yeah. So it's giving me the ability to randomize this deck immediately. I can probably defer until loaded if I wanted to. Then what will happen is it'll update the index. This is a dynamic data message. This is part of the reason why I wanted to tie into dynamic data, because it does some of this index awareness stuff for us out of the box just by adhering to this interface. So using that interface, we can then update the index, which will change the index on the card itself. So let's go back to our test-driven stuff and let's talk about the act of shuffling, right? Like, what do we get when we start doing these shuffling concerns? So we're going to go back to our tests. Why is there red? Why is there... Oh. Generic type parameter where T is of type iCard. That's why we has red. Red gone. Woohoo! We are winning. Alright. Actually, we're going to expand these things out as well. Everything in the file. Yes, I'm extremely anal about white space. We actually want to put that, I think, the shuffle. So we'll do public class, the shuffle method, and we don't even have a shuffle method yet, but that's fine. And what we wanted, the first thing we want to do is that let's create an XUnit test and say given cards when shuffled, then the order has changed, right? So when these cards come in, we're gonna go grab this real quick and just do some copy pasta. Right, cards. All right, so when we first go down this road, when we're giving cards, when we call the shuffle method, then we want to verify that they're not in the correct order. If you remember, our test deck will put cards in order and give them a numeric value 0 through 54. So what we're going to do is 0 index versus 1 index. I'm so bad. We're going to create a card deck. We're going to provide it playing cards. We're going to call this our system under test, and we're going to do new deck card fixture of playing card. I wish it would just tell me that. Just handle that for me. It should know the type, right? With cards, pass it cards. What we need now is to do a shuffle, which we don't even have a shuffle method, which is like, yay, we're getting into our core tenant now. We need to provide a shuffle method, so we will do public void shuffle. Do the shuffle. I know that's the hustle, but just. All right, so we'll have this shuffle method. So now we are red again, or we should be green again, right? Okay. Then our expectation of the shuffle method is that the system under test should not be in ascending order. Sounds right, right? So let's go ahead and let's see if we can. Yeah, there we go. So let's run all our tests just to make sure we didn't break anything. Because I've done that before. It's like, oh, I create a brand new test and think I haven't changed anything, and then I don't run the old tests, and lo and behold, I broke something. Oh. Should not be in ascending order. Let's go back and look at that. The randomize immediately should not happen. Should not be in ascending order. My brain is like. Dun dun dun. Can you see the problem, kids? I see the problem. Yeah, we'll come back to you. You can stay red or yellow for a moment. Okay, so now if we rerun our test, all right, breakpoint debugging time. All right, so it's gonna hit this. Loading the full. Oh, so we never hit our breakpoint. So what's getting loaded into the full deck? I'll put a breakpoint here for when we call for the enumeration. Pardon me. Probably need more coffee. All right. Come on, Cash, you can do it. Okay, so the full deck has 54 cards. That's what I would expect. Now the remaining cards, let's go look at them. Right, so the first one will have an identifier. Let's do this. Identifier and index. There we go. All right, so yeah, the right now it. Oh, we didn't. Should not be in ascending. Ascending versus descending? Is this a bug? Ascending. Just because now I have to make sure I'm not going crazy, or I'm not having comprehension issues today, because it happens. It's funny, like one of the hardest things we do is Boolean algebra, and it's like everything that we do. That's a problem for me because now I feel like this is a brittle test. We're gonna trudge along anyway, but oh, is that why we need the other eye comparable? Oh, that might actually be the reason. If I go think about that, full deck playing. I think that's exactly why I did this the last time. Yeah, it says that it's not used here either, but I feel like the second I do that, okay. So maybe we exposed an issue with a library that we love a lot. Maybe we don't know what's going on. Empty collection. Elements are compared using their compared to object implementation. So then that means that this needs to be of type compare, of I comparable. Ooh, it's using the default compare. Does that matter? I don't think that matters to us. Okay, we can give it the comparison method. So let's do this. Ascending, right? And then we're gonna say x comma y x dot identifier that equals y dot identifier, right? Because that's what we want at the end of all of this. Right? We want to say that one thing's identifier. Oh no, what is that func return? Ooh. Oh, that's weird. It wants you to return the actual comparison itself. But we already have the compare to. We already have the. Alright, so let's do this then. X dot compare to y. Right now, we do this. We'll see what happens. I'm not convinced. Now I feel like I broke fluent assertions. Because it's definitely me. It's definitely my consumption of the library. That's the problem. Compare to. I thought I was supposed to use the object implementation string comparison. So now my brain has to know. Debug. I have to know. What did I do wrong? If I can't tell after this debug session, I'm just going to move on because I know that the rest of my tests somewhat work. Alright, uploader, remaining cards. Okay, so it's comparing 0 to 26, and it's saying is my string comparison. Invariant culture in your case. I don't think it matters. Like it just shouldn't matter. All right. I can get rid of this. Should not be in ascending order. We're just gonna keep moving. That's really weird that my test passes though, and I'm sure that there's a very great explanation for why it passes that I just don't feel like looking into right now. If it fails now, I'm gonna laugh. Okay. Alright, so let's go implement our shuffle method then. So what we want to do is when the shuffle thing does its magic, we just want to on next the unit dot default. Right, we just want to tick a value on that observable pipeline that says that a method has been called. So let's just run that again just because. And then we'll move on. Okay, so we've got the count property and we've got the shuffle method. Okay, so now we've given our card deck the ability to shuffle. Let's go start pinning some tabs so I can start removing some stuff. Let's pin the readmes. Deck tests. That's all stuff I needed in order. Okay, so let's just close all but pin. Cool. So if we go to the readme, we've got the shuffle. We've got the concept of shuffling remaining. We haven't done anything about drawing yet, so I think we're gonna talk about this reshuffle after we get to the drawing. But now we've got shuffle under our belt, so let's go ahead and talk about cutting the deck, right? Because we shuffle the deck several times, and then we usually cut our deck at some point, right? So let's go back to our card deck, and let's have a method for cutting, right? Usually when I cut a deck or when people cut decks, sometimes they'll cut the deck and they'll cut it in half, but some people like to be funny and make it into a whole bunch of little piles and then put those little piles back together. So what I looked for was .NET 6 has a chunk implementation. So I basically just kind of stole .NET 6's chunk implementation and brought it into my because this library won't just be released for Net Standard or not Net Standard for Net 6. It'll also be released for Net Standard 2.0. So if I ever decide to release it, I don't know if I will, but anyway. So to keep that backwards compatibility, I wanted to make sure that I could do both. Let's. Oh joy! You guys will have to give me a quick moment to go do some business. All right, apologies. We're gonna have one more interruption here in another couple of minutes, so I apologize in advance. Okay, we're at cutting the deck. Right, so some people will actually want to cut the deck multiple times. I was figuring I would use the .NET chunk um, implementation, and I'm just going to grab this and make it a local function here inside the cut method. There we go. Paste that in there. And then what I'm going to do is I'm going to give the ability for the cut method to have a number of stacks. Right, so the number of stacks that you want to cut it into. And I'm going to default that to 2 because the average person is just going to want to cut it in half. But some people are going to want to cut it more, right? And then you can call the cut method n number of times, and it should give you a different result each time. So from that perspective, what we're going to do, we're going to take our chunk size is going to equal the underscore deck cache dot count, and we're going to divide that by the number of stacks, or check to see whether or not the number of stacks equal is that, and then we're going to take the stacks plus 1, or we're going to return stacks. There we go. All right, so now we've got the size for the chunk, and then we're going to physically take a stack and do var stack. New stack of t. And then we're going to do for each in the stack. We're going to do var chunk, and then we're going to do another for each real quick, and we're going to say we're going to take the chunk and we're going to explicitly reverse it. Chunk dot, that should work. Come on, you should be in stack t. Oh, that's what it is. I have to chunk the stack. Derp. There we go. Now that we've... Oh. No, we're not chunking the stack. Sorry, we're chunking the get cache dot items dot chunk. So my concern here is that this won't give us full ability to cut the deck if we haven't reshuffled all the cards in yet. But again, that's a tomorrow problem. I'm going to keep this as lightweight as I possibly can. So I should have a reverse on here now. Now I can reverse it. And then this is going to be the individual card. And then we're going to do a stack dot push. And we're going to push the card onto the stack. And then after we get done with all of that, we're going to do a underscore get cache dot edit. Ooh, that might actually be interesting later, is to do like an edit diff update. And then we'll do update dot adder update. And we may optimize some of this stuff later. The stack. Okay. All right. So now we've given ourselves the ability to chunk this on the cut size. So let's go write some tests around that, right? Because like, we want to be able to verify that that this works the way we expect it to. And I may have fat fingered some stuff, so that'll be a good litmus test as to whether or not Rodney's actually paying attention to what he's doing today. So let's go to the test. Come on, you can do it. Let's go here, do public class the cut method, right? And we'll construct an XUnit test, and we want to make this a theory. And we're going to do class data, and we're going to provide the type of cut a full deck, right? Because this is going to test what we're trying to simulate is cutting a full deck. So that is going to, oh, yeah, I guess I probably should have given the actual designation other than just giving when then. So we'll worry about that in a second. To our test stuff. So this test is just going to be card deck of playing card. I think that's going to be, oh, that's right, it's going to be test card deck card ordered by identifier, right? So it's going to come in ordered by the identifier. Yep, I get it. You don't know anything about the missing reference types, and then all we're going to do is move you out to your own file anyway. So there we go. All right, so we've got a set of tests that will test cutting a full deck. This will take in an I enumerable of playing card. That would be the cards, and then the number of stacks. Right, so given card deck of type playing card, where we have a system under test is going to equal new card deck fixture for a playing card, and then we will provide it with the cards, and that's going to be with the cards that we get passed in. So we have cards, so given, oh no, we've already got given cards when cut, then the order should be different, right? That's simple enough. Let's see, so we have system under test. We're going to just do cut, and we're going to provide it the number of stacks that we want to cut it in. Defaults to 2, but we'll give it that. And then we'll say system under test dot should not be in ascending order based upon the identifier, right? That's what we'll determine. Now we've already said that this thing is wonky, so maybe we'll try it again. We're just gonna be a glutton for punishment today, and we're just gonna continue to beat ourselves over that over the head with that one. See how this goes. Break. Yay, it broke. Okay, so maybe we need to go back and do the same thing for the shuffle. I think that'll do it, right? So should not be in ascending based upon x dot identifier. Okay, that should do it. Okay, so now we're saying that these things, one of these things is not like the other. We are doing that. So now if we go back and we go to our cut implementation, we'll go ahead and run these tests. All right, now they pass. Cool. So the order will be different after we cut. Great. Now we're not getting into any like explicitly awesomely savvy stuff around, oh, verify that this chunk is there and that chunk is there. We just care about the fact that, hey, we've cut it, things are no longer in the same order. We could test that if we really wanted to. I don't think I care to until like I need to test it. That's one of those ones where it's like I could write the test now and waste a whole bunch of time and it still work, or I could use the object a little bit, verify that it works, and if I run into an issue, I'll identify the issue and write a test that to make sure that that specific scenario passes, and then I'll fix the bug. So to each their own. But we also want to test. I'm gonna grab this. I'm just gonna do some copy pasta here. Don't tell anybody I did that. Actually, I'm not even gonna copy paste. Haha, I'm smart. I am going to use Rider's ability to just duplicate lines. So given cards, this should say cards. Cards. When cut, then the count should be the same. So it should, when we cut it, it should still have a count of 54 cards, right? Oh, I guess I could just do cards.count. Yeah, I'll do that. Count. Get ready for it. Get ready for it. Possible multiple enumeration. Yay, my favorite. I love this one. Enumerate it to a list. There we go. Bam. Oh, yeah. You should be smart enough to do that without me having to do anything. You should just be like, oh, this is the next problem, and fix it. That'd be amazing, right? That's like me being really, really lazy, though. Okay, so what we're going to do now is we're going to test it when we shuffle. Yeah, actually, I don't even know if that matters, right? If we shuffle it and then cut, that the order is different than what it was. I think we'd have to give it an explicit order and expect it. But because we're doing a randomization, I don't really want to do it that way because all right. So we've at least tested the fact that we can, just for crits and giggles, let's go ahead and cover all the tests and see how far we are along test coverage. Not that test coverage as a metric is like the most important thing, but it is a metric. We should pay attention to it. 413 lines of code. How many of them are covered by the simple tests that we have done? 59%. Hey, I'll take that. I'll take that. All right, let's get rid of that window. So now we've taken care of the ability to cut, right? So we've done our cut implementation. We're doing our chunk. We are randomizing, doing the stuff and things, updating the cache where we need to. Where is this method? Oh, okay. Yep. We're using the actual chunk method under the hood then. Cool. Get rid of that. So we can now cut and shuffle. So I think the next thing we need to be able to do is to get cards off of the top of the deck. Card deck. Shuffle, cut. And then public I read only collection of T. Call it draw. So the draw method is going to also take in account. Why is the draw method going to take into account? Because it makes sense to. Yeah, it definitely makes sense too, right? Because like I may want to, like in Uno, I might want to draw 4. In blackjack, I might want to draw 1. So what we're going to do here is we're going to do var cards equals the remaining cards dot to list. well, let's back up. Oh, it's not a list. To list dot as read only. All right, so we can verify. So let's go back to our stuff and things, and let's start looking at the drawing. Alright, yeah, so we want to throw an exception, I think. I think that makes sense, right? Like if you go to draw cards from the deck and there are no cards on the in the deck, you want to throw an exception and say, hey, you're out of cards. It seems reasonable. The cut method, let's do this. Public class, the draw method. So given no cards, when we draw, then there should be an exception thrown, right? We definitely want to throw an exception and say, hey, you are smart. We also probably, I'm just going to list out a couple of tests, right? So we also probably want to test that giving cards when we draw, then the count is reduced, right? I think that's a reasonable expectation for a test. I think we want to test that. Start doing the copy pasta. Then the return count is correct, right? Like if I say I want to draw 7 and I draw 8, that might be a problem, right? And I think we also want to test that given we draw something, that the deck remains in the correct order. Right, so the act of drawing shouldn't shuffle or cut. All right, so now let's go up here and start doing the thing, right? So let's throw an exception. Let's do that one first. So let me grab this and put that on. That's not going to be on my clipboard. Let me do it over here. Card deck of type playing card is going to be our system under test. We need a new card deck fixture of type playing card, and we are going to say that there's going to be a var result is going to equal a record thrown record exception. Yeah, okay. Record exception, and we're going to do system under test dot draw 1, right? Shouldn't matter what number we put in there. Maybe we default the draw to have a number of 1. Don't know. I'm not gonna get into that just yet. But that should record an exception. And then I don't think we care what type right now. I think we're just gonna verify that the result should be of type exception, which basically denotes that it is not null. Same difference, right? We could check to see if it's null, we can check to see if it's of the type. One way or the other, we're getting the information that we want. So we're going to go ahead and run all our tests again to verify we didn't break anything along the way. Or at least nothing major. Make it some water. Yay! No exception has been thrown. What does that mean? That means we didn't check the count first. That means we need to go over here to our draw method and say if underscore remaining cards dot count is less than the number that we're sending in, right? Only if it's less than. If it's equal to, we can draw. So yeah, if the number of cards that are left on the deck are less than the number we want to draw, then we want to do, we just want to throw new exception, right? And I think we want to say, you ain't got no cards. You ain't got no cards. Oh, I can hear my mother yelling at me now. All right, so now we go back and retest our bit about drawing. Yeah, those are all green right now, so we're gonna make them red in a minute. Expected type not to be. Oh, should be of type, and now when I click run button, everything worked good, yeah? Yay! Okay, so it throws an exception when it should be not enough cards, not enough cards. When draw, then exception thrown. Cool. So given the fact that we have cards, right, let's go back over here. Let's grab. We're gonna grab this one last test fixture. I think it may not be the last one we grab, but we're gonna grab another test fixture. We're gonna hit the Explorer real quick. Draw from a full deck. That needs to be this. We're going to copy that. We're going to move it. Okay, so it's another one where it takes the deck and the type. Okay. So we're going to create a theory. Class data. Type of that thing, and then we're going to say enumerable of playing card. Oh, we don't need this right now. Cards, int, draw. I assume that's the number we want to draw, right? So let me copy that up, put it on my clipboard, paste that in, right? So I have a system under test. I want to give it cards. It's got cards now, so it's happy. And then we want to say var result. Oh, we don't care about the result. We're just checking to see whether or not the count is reduced. Draw. Draw based on the number of drawn. Then system under test dot count. Oh wait. That should have count. Should have count, sorry, of cards dot count dot minus the draw amount, right? So we're testing to verify that we have the precise amount. Here we go. Yep. Now you're going to tell me that you're smarter than the average bear. Use, no, just use, there we go. All right, so once we draw, we should have the original minus whatever's left, right? So let's go ahead and run that test. I hope that fails because we haven't actually implemented that yet. Yeah, we're not actually doing it. Yep, perfect. So that test should fail. It should fail. All right, so we got a failing test. We will now go to our draw implementation and we'll say what? What are we going to do? How is this going to work? We are going to... Oh, that's interesting. We can do it that way. So what we'll do is we'll do... var cards equals underscore remaining cards dot to a list. What we're going to do here is we're going to say var drawn equals cards dot where the index is less than the number we want to draw dot to list, right? And then we're gonna do underscore deck cache. So we're actually gonna physically remove them from the cache. That's how we're getting around that other problem, I realize now. Remove keys of removed. Oh, call it drawn. Drawn. So yeah, so we're physically going to remove them from the cache. Technically, I could possibly just filter them, but I think that removing them actually makes it all better, considering the fact that we have the full deck as a property in here. I think it's better to just use the cache as a proper list that can then bind out. All right, deck cache. Okay, so then I just want to return the drawn as read-only, right? And that should get me where I want to be. So now I'm going to go verify. No, it just did one. Yeah, okay, so I did that. So then now we'll say given cards we're going to verify that it actually returns the amount. So this is going to be pretty much the same test. Oh wait, we got to get all the test bits, don't we? We're going to copy pasta. And we're going to say var result equals that. And we want to do result that should have count of draw, right? And then we're going to verify that the ordering itself hasn't changed. So let's go back to the deck test. Yeah, this test is going to be slightly different. I'm actually just going to copy these bits over. Yeah, we're definitely going to copy those bits over. them to write. New playing card in a card deck fixture of playing cards. Why are you has one parameter but is invoked with 0? Oh, did I do that? Oh, I am so smart. I am so smart. SMRT. It's okay. I can fix it. I can do better. Let's give it another parameter. There we go. Yep. There we go. So now we'll run all of the draw method tests and verify that they pass. They should, right? Because we implemented it pretty well. So when you draw, you should have that count when you draw off. We're saying that it returns the correct amount, the count is reduced by the correct amount, that the deck remains in order. Okay, so then let's go back to our README, and now I think we've got our draw method. Done. Right. So okay, so let's get back to this remaining in this shuffle. How do we want to do? How do we want to do this? All right. So the shuffle method. I think we're gonna need a couple of more tests. I think we're gonna need. So I think we're going to take theory bits here. So we're going to want this to be a theory. We're going to dump it. Don't do it. It's a trap. I'm going to dump it. There's me clicking buttons. And we're going to say given cards when we reshuffle, because like now we're going to handle the, okay, we've expended all the cards and we're going to reshuffle and start a new hand or whatever the case may be. Alright, so what we're saying here is we're going to do this. No, not giving cards. Given that we've drawn from the deck, yeah, we actually explicitly want to draw from the deck. So let's do like draw. Let's draw 7. 7 seems like a good number. We'll just take 7 cards off the top, and then we will explicitly do a system loader test dot shuffle. This is where it starts to get weird, right? And then we'll say that the system loader test should have count of cards dot count. Yep, I get it. Yep, you're gonna enumerate to a list. We'll have playing cards. We'll get rid of the excess. Oh wait, it's gonna let me do multiple. Do it in the project. In the whole project. So now if we do this, run this test. All right, I'm gonna need to step away for another quick moment. I will be right back. All right, apologies for that, folks. Where were we? Okay, we were checking to see when we reshuffle, then we should have the same count that we left off at. That test fails, which is good because right now, yep, we've taken 7 and we expect there to be 54. So how do we handle that? I think what we're going to do is we're just going to create a public enum shuffle strategy. And I think what we're going to have is we're going to have a concept of shuffle the remaining versus reshuffle. Should we do a remaining? Let's do current versus the deck, right? So we'll shuffle what we currently have in the deck versus the whole deck, right? So let's just give this 2Ks, right? And then this will be shuffle all the cards in the deck. All right. Cool. So now what we're going to do is go to our shuffle method and we're going to change some things around. What are we going to do? We're going to add a shuffle strategy, right? This thing is then going to be, we're going to say if the strategy equals deck, equals shuffle strategy.deck, we're going to call a method that says what is the concept of that when you're talking about like the domain of a deck. Would that be not rebuild? Let's just call it restart because it's internal anyway, so we don't care. So let's just call it restart. Restart. Oof. Don't do that. Restart. So we'll restart the deck. And then we'll call unit.default. And we will default this to the current, thinking that that's what we will want most of the time, and we'll explicitly say that we want to shuffle the entire deck when we want to shuffle the entire deck. Maybe that's good, maybe it's not, I don't know. We'll find out. But we're going to have to implement this method restart, rntwee. So let's do a private void restart. And I think it goes a little something like, we want to underscore deck cache dot edit update dot load underscore full deck. Right, so the restart will restart the deck at the beginning. Let's go chop the line. What? It doesn't give me an option to chop the line. Okay, we're gonna chop the line there anyway. It's probably because I'm not actually hitting the margin. Okay, so now what we're saying is explicitly when we shuffle the entire deck, reset. That sounds better. And then I guess that means that here, first thing we want to do is call reset. Seems weird, but yeah, that lets me know that the name of that method is probably wrong, but we can come back to method naming later. There's a whole like course on how to do it well. Not, there may not actually be, but there should be, because naming is hard. Okay, so we're just gonna reset the full deck. No, I can't actually make this static, so it doesn't matter. So I'll leave it as private. It'll be fine the way it is. So then how do we test that, right? So then we want to come over here and we want to say when we shuffle, we want to use the shuffle strategy of the deck. So I guess it's not a reshuffle. I guess when we shuffle, then we get the, given that we've drawn, when we shuffle, we shuffle the deck, then the count should be correct. So now we go run this test. The thing should pass. Okay, it's green. So what other things do we want to test about the shuffle? So I guess now we want to test that if we use the other strategy that it doesn't do this thing. I guess that's the negative test that we want to do. So let's go ahead and do this. Given drawn, when shuffle, current. Right, so when we just call the default shuffle method, then it should have. Ooh. We're gonna go grab more test cases. Let's go. This is going to be a test card deck. This is going to have to go move it. This is the one that we wanted, right? So yeah. So when drawn, when shuffle current. So I think we want this, and we want int draw, and then we want to give it this, the number that we want to draw, and then it should have the count of that minus draw. When we've drawn and we shuffle current, then the count's correct. When we've, maybe we want to change this to, yeah, let's change this to, and then we'll have int draw, just for posterity. Because it's already a theory anyway, so we might as well just make sure that it all works. All right, so let's run all our tests at this point and see where we're at. Yay, all my tests pass. Let's see if there's any more tests that we can write to cover stuff. So I guess now with the count property, what we want to do is duplicate this and say given cards, when we draw, then the count should decrease. The count. And maybe we're kind of testing that somewhere else. That's why I said like this pattern is like has good and bad qualities about it. Where, let me see, do we have a draw? Yeah, we have a draw from full deck. Yeah, so that's what we want. We're going to use those. Dims tests there. Int draw. Right. Yeah, okay. And now we're going to do when draw whatever the draw amount is. Then it should have a count of cards dot count minus draw. Welcome to the possible multiple enumerations. Introduce variable. Oh, that's weird. Oh yeah. Oh, because yeah, there we go. Now it picks it up. And now it doesn't want those anymore. So let's do that in the project. So now we say that when we've drawn a number of cards, then the count on this object should reflect that. That seems sufficient. What else do we want to check? Yeah, what we wanted to test was like if we draw a certain number and then we need to shuffle in the middle of it without reshuffling, that the act of shuffling doesn't add cards back in, right? So let's go look at the shuffle stuff again. Let's collapse all of these, expands them. That collapses all. There we go. So let's go to the shuffle. Let's go to this one, right? So let's then go to the end. I think we're just going to duplicate all of this. Yep, we're going to duplicate that. We're going to say, given that we've drawn. Oh, wait, no. I'm going to do this in cut. Given that we've cut, yeah, okay. We'll change the draw. We'll cut a drawn deck. So when we pass in the default and no, we're testing the cut method. There we go. This is why copying and pasting is bad sometimes, because I'll copy and paste stuff and like not even pay close enough attention to what's going on. We'll draw the draw amount, we'll cut, and then it should have count minus draw. Should have the count minus the draw. Drawn equals, and let's say the subject should not contain the drawn cards, right? Just so that we're like verifying that things are working the way they're supposed to work. I don't know where that test class came from. I should just copy over all the test classes at the beginning and then just been done with it. But that would denote that I have intelligence, and I don't think that's the case. So it would have been way easier. Yep, yep. You brought in all this stuff. Oh, it already exists. So then why did it not resolve? Oh, because I am smirt. There we go. I am smart. So here, and we'll do this. We'll duplicate that, and we will duplicate that, and we will duplicate that, and we'll say this is 7, 6, 7, 8. Okay, let's just keep it consistent. Let's just double up the numbers, right? 10. There we go. So now we've got a test card. So we'll cut by that number and shuffle by this number. I'm sorry. We'll cut by this number and draw by this number, right? So in our test, where's the usage? Where's the usage? Usage. All right. So int stacks. Right, so just to increase coverage of the API surface, right? So that way we're forcing ourselves to use more than just the defaults. Oh wait, that shouldn't be shuffled, that should be cut. Yeah, let's run it all again. And yeah. Index must be within the bounds of a list. Where are we getting that exception? That's an interesting one. Oh, it's in the calculate. Okay, so I know that I have to write some tests specifically around the dynamic data bits that I wrote, and I haven't done that yet. So this seems like it's a issue that's happening in here. But that's fine. We can handle that on another day. Random. Possible null reference. Okay. We'll come back and deal with that another day. Hopefully, if we just rerun this thing, it'll magically work. That seems like a concurrency issue in my brain. So yeah, okay. So now we've got our card deck, right? We can randomize it immediately, or we can defer randomization. We can, yeah, we only do that once. We can and will reset the set to full, maybe. Anyway, figure that out. So we reset the deck when we take in an IEnumerable of cards. We can shuffle. We can either shuffle the current or we can shuffle the entire deck. We can cut by any number that we want to. Ooh, yeah. I think future state we probably need to. So I'm gonna put it to do here. Yeah. Oh. runaway keyboard again. Which means I need to clean my keyboard, folks. Okay, so yeah, we'll check. In the future, I think what we need to do is need to check to make sure the number of stacks isn't greater than the number of cards left in the deck. We might get an exception then. Maybe we need to test for that. You know what? We'll test for that real quick, and then if it breaks, we'll. If it. It's not gonna break because we're not explicitly throwing the exception. So let's just do it now. Let's just do it now, and then we can check. But like, we've got the ability to cut the deck. We've got the ability to draw from the deck. Yes, let's do that now. Let's do if. Oh, let's be right. Let's do this right. Let's write a test first on the cut method, and let's say all right, when we cut a full deck, I don't think I need that. I think I explicitly just want to test. I think this just needs to be a fact. I think I can get away with that. And I can just say, no. I still want to do a theory. I just want to take a full deck. Just a full deck. Full deck test. Wow. Learn to spell, Rodney. Alright, so now we've got IEnumerables, playing cards. So when we cut, yeah, let's just cut it by like 60, right? We want to create 60 piles. Given cards, when cut, then an exception should be thrown. Exception thrown, right? Okay, there we go. So now exceptoin. Alright, so we actually need to do this. Do var results equals record dot exception. Give it an action. That's our action. Result should be of type exception. All right. It's gonna throw an exception, but it's gonna be weird, I think. It may not throw an exception. I actually don't know what this is gonna do. We are officially off the rails. Yep, okay, that's the. Oh, no. What? Let's check that one out. Let's start yanking some of these. Right, so the stacks, the count, the chunk size going to be? Chunk size is 60. So I guess their implementation of chunk handles that? Or is it that some of them just happen to be null at a certain point? So I think we want to impose it, even though it doesn't seem like it throws an exception. I feel like we need to check to see like if the stacks is greater than the underscore deck cache dot count. Throw new exception. Not enough stacks. Number of stacks requested. Yeah, that seems sufficient, right? That seems like it's okay to me. All right, so go back to our README. So we've got the ability to shuffle the remaining stuff and to shuffle all the things in our deck data structure at total. Let's move this. The data structure itself is only 89 lines of code. Seven lines of code. It's not horrible. All right, so I think we've done what we set out to do. We've tested a lot of things. We tested the remaining count. Yeah. Okay. See, I think I'm pleased with this so far. So like now, looking at the API surface, right? If I was to just look at the collapsed bits, we've got a structure that allows us to shuffle, cut, and draw. We can cut by a given number of stacks. We can draw. Default that to 1 just to make life easy. And then we always project out the remaining cards. We can reset internal to the object. This seems like good to me. I don't know. This seems like good. I think I like this. This gives me a nice composable piece around a card. So I just define whatever my card implementation is, whether or not it be a regular playing card, a Uno card, I don't even know what other type cards you'd want to play with. And yeah, is that my same index out of range? Yep. Okay, so that's my dynamic data pieces that need to be fixed. So I won't bother with that too much. Or explicitly test it. Oh, it doesn't see it as a count method, or us testing the count method because we're using the have count fluent assertion. Okay, that's weird. That's interesting, but weird. Well, weird, but interesting. Okay, and then the randomization we know works because we've got tests that verify that the shuffle method is doing things. Even though we got that false positive in the beginning, I think we're okay now. So where I think we are is at a good stopping point. I think this proves out a simple data structure for creating a deck with unit tests provided, but what are you telling me? Index must be within the bounds of the list. I get that. Oh. Okay, it all greens that time. That might be a concurrency issue, is what that sounds like. But anyway, I think this is a good stopping point. I think that this is has been a fun little exercise to give you an understanding of how you can create a new data structure, extend from what currently exists inside the .NET framework, and we've got a good test suite around our functionality. So if we decide to come back later and break something, we know exactly what we broke. We've got our tests set up. We've got our card deck defined. So yeah, maybe one day, one of these days, I'll actually put this thing out there on the NuGets, and people can consume it if they want to. Again, it's consume at your own risk. It does have RX involved. You won't see it, but that doesn't mean that it's not there. Some people swear off RX and won't use it because they think that it's, I don't know, bad for their health. Uh, but I embrace weird and difficult things quite often. If I didn't, I probably wouldn't even be a developer. I'd just be, I don't even know what I'd do. I like the weird, crazy, hard things to tackle. So, uh, this gives you an understanding of how this works, how we constructed it, how we are taking a test-driven approach to creating the object, and we'll put the link to the GitHub in the on the YouTube. Thanks everybody for joining, and I appreciate your time. Have a good week.